So water is weird. Water is extraordinary. It's essential for life. It's the most important and most common liquid on Earth. Most of the things that we think of as liquids, like, my energy drink here, that's not a pure liquid, it's an aqueous solution. The liquid here is water. So water is the main solvent in living organisms and in our environment. Water is weird because it has a low molar mass, and yet it's a liquid at room temperature, and that's due to hydrogen bonding. It has a very high specific heat capacity, 4.18 joules per gram degree Celsius, when most other things are less than 1. And so that has a big effect on how it can moderate climates. Another weird thing is that it expands upon freezing. The volume expands. And so this is why pipes will break when they freeze, why if you take a water bottle that's full and you stick it in the freezer and you let it freeze solid, the plastic bottle is going to break. It'll break a glass bottle. Frozen water freezing is actually very powerful. Water expanding when it freezes causes this to happen when your lettuce gets too cold. Here's a nice head of lettuce, and here it's been in that part of the fridge that's a little too cold, and it got all cold and crusty. What happens is there is water in each of the cells, and as it freezes, it expands and it bursts the cell membranes and essentially destroys the lettuce. This is similar to a graph we looked at earlier in this chapter, but here we're looking at several different groups in the periodic table. So we have group 4 and group 5 and group 6 and group 7. And we're comparing the boiling point with the period that the element is in. And so for group 4, we see that all of these compounds are nonpolar, and so they have a nice trend here that as the molar mass increases, the boiling point increases. For the other 3 groups, we see a nice trend for hydrogen, phosphorus, and chlorine, and the ones below, but for oxygen, fluorine, and nitrogen, they severely break the trend, and that is due to hydrogen bonding. If you've got fluorine, oxygen, or nitrogen bonded to hydrogen, you're going to have hydrogen bonding, extra strong intermolecular forces, and that's why the boiling point of each of these substances is much higher than predicted by looking at the patterns for the others.